Hello and welcome to eMind's Technology. This is BGP continuation of part 1. And my name is Jay Chandran here. Now in the previous video we saw up to BGP most appropriate. Where is BGP appropriate? Where I can use BGP. Now what we are going to discuss now, where we are going to start, is where it is not appropriate, where I should not enable a BGP protocol. When we will have a limited understanding about this protocol, definitely we should not go for this. Why? This may spoil your network sometime if you will not have a clear understanding about BGP. And then if we will have a single internet connection, meaning if my autonomous system is connected to a single ISP, meaning there is no multi-homing, then there is no need of BGP. And if my processors and memory are not so good, poor, old router, then BGP is not a best protocol that I can run. The reason why, BGP needs lot of memory, lot of processor. Now BGP is a path vector protocol. Why? One reason is it finds the shortest path, shortest number of hops, where one hop is equal to one autonomous system. And this is a protocol that works on top of TCP 179, right? So it's more reliable. Why? It uses TCP. It's not like RIP. RIP uses UDP. UDP 520 RIP uses, whereas EIGRP uses BGP uses TCP 179. It works on top of TCP 179. What is the meaning? Means it works on top of TCP 179 means if you will have a connectivity, if you will have an IP path to some destination. Say for example, I can ping from router 1 to router 10. Then I can enable BGP only on router 1 and router 10, and for router 1, neighbor will not be router 2 or router 3 or router 4, but neighbor will be from router 1 to router 10. Even though you don't have a neighbor in the middle, still BGP can form neighbor with a remote router because it works on top of TCP 179. Now BGP also sends incremental and triggered update like EIGRP, means there is no periodic update. Like hello messages, BGP sends keep alive messages periodically, every 60 seconds actually. It is not mentioned here. Every 60 seconds they will send a keep alive message. And BGP has rich metrics. It's very rich. We call it as attributes. And by design itself, BGP is designed to support a huge network like internet, right? So these are the good things about BGP. Now BGP has three database, or BGP has three tables: neighbor table, BGP table, and a routing table. Now neighbor table will have list of neighbors. We'll have all neighbors that is directly connected. You can see that by typing command show IP BGP neighbor, show IP BGP summary, the two commands. Now BGP table is called as a forwarding database. Why? The forwarding decision, the path that is eligible for forwarding, the decision is made in this table, the algorithm behind this table. List of all network learned from each neighbor you will find in that table, and also the various paths via which you can reach those networks. Along with that, you will also see the attributes on each path. So if you want to see this table, show IP BGP is the table, is the command to see the table. Show IP BGP. Now the routing table will show you the best route, best path to various destinations. The command is show IP route. That will show you the routing table. Now these are the three tables. When I configure BGP, I'll show you in the following videos. Now BGP has message types: open message, keep alive message, update message, and notification message. Open message means before forming neighbor, a packet is sent which is called open message, which talks about the hold time and the router ID. Like OSPF, BGP also selects the router ID, but not spoken much in BGP like you speak in OSPF. The biggest router ID, the biggest IP address will be the router ID. And keep alive messages are sent every 60 seconds. Updates, information for one path, right? That's called update. If a path change happens, if an attribute on a path for a particular network changes, then it is sent as an update. Notification, when a particular network goes down, when a particular path goes down, it is sent as a notification. If a connection is closed, then it is sent as a notification. So these are the four different types of message that we have: open message, keep alive message, update message, and notification message types. The next thing, in BGP we have a concept called peers. Peers. Peers is nothing but neighbor. Now we are going to learn about eBGP neighbor and iBGP neighbor. What is eBGP and what is iBGP? eBGP is nothing but external BGP. iBGP is nothing but internal BGP. External border gateway protocol or exterior border gateway protocol, interior border gateway protocol, IBGP. IGP is different, iBGP is different. BGP has two flavors, iBGP and eBGP. Now BGP can form neighbor like this between C and A. A belong to different autonomous system, which we called as eBGP, external border gateway protocol. BGP can also form neighbor with C and B. See, C and B are not directly connected, but OSPF is running on C, D and E, meaning there is a reachability. If I ping from C, I'll ping B. Means there is IP path. If IP path is there, TCP 179 can work because already path is there. So C can form neighbor with B even though B is not directly connected, but condition is it should be on the same autonomous system. On the same autonomous system, neighbor need not to be directly connected. Important concept. Inside the same autonomous system, neighbors need not to be directly connected. You run some IGP protocol like OSPF. If there will be a reachability, then neighbor can be formed. Whereas between autonomous system, neighbors, peers must be directly connected. Right. Now BGP peer is known as BGP neighbor, is a specific term that is used in BGP speaker for BGP speaker that have established the neighbor relationship. Any two routers that have formed a TCP connection, because it is BGP TCP 179 protocol, any two routers that has formed a TCP connection to exchange BGP routing information, what exchange? They will send open message and then they will form neighbor. Then they are called BGP peers or neighbors. Now BGP, I was telling about eBGP, external BGP and iBGP. External BGP means running between autonomous system. Here D and Y is eBGP neighbor, C and X is an eBGP neighbor. When BGP is running between neighbors that belong to different autonomous system, then it is called eBGP. eBGP neighbors by default need to be directly connected. iBGP, meaning they are inside an autonomous system, not between autonomous system. Then you may have a question, what? You run BGP inside autonomous system? Yes, yes, but not for routing purpose, not for routing my packet inside an autonomous system. The purpose of this is different. We'll talk about the purpose of running BGP inside an autonomous system after some time. But there are cases where we will run BGP on all our inside routers. But the purpose is not for finding the best route within an autonomous system. For that we have OSPF, EIGRP, REAP. This has different purpose. Now, if you will run BGP within an autonomous system, then it is called as an iBGP protocol. And again, I am telling you, neighbors do not have to be directly connected. Right. Now, next is, iBGP in a transit autonomous system. Meaning, why do I need iBGP protocol within an autonomous system? Meaning, why should I run BGP inside an autonomous system? See, if I am not running a BGP inside an autonomous system, person from A cannot ping F. Router A cannot ping F because on A and F you don't run OSPF. They are different autonomous system. Now A can reach B because it is BGP. F can reach E because it is BGP. But after B, packet don't know how to route the packet. So the packet, packet will be getting dropped on D and C. It's a black hole. To avoid that, there are three solutions. One is put a physical connection between B and E. B and E put physical connection wire between B and E, problem solved. If it is not possible, redistribute on B and E. Redistribute BGP into OSPF, OSPF into BGP, BGP into OSPF, OSPF into BGP. That solves the problem. Or run BGP on all 4 routers. Right? We'll continue in the next video.